So this is just going to be a quick introduction to cycloalkanes, and then I have a couple of other videos where we look at drawing cyclohexane and also what happens when we add substituents to cyclohexane. So we know that for an sp3 hybridized carbon atom, the ideal bond angle is 109.5 degrees. And if cyclohexane or cycloalkanes were flat, they would have considerable angle strain where the angle differs significantly from the ideal 109.5. And it's also true that if the ring was flat, then there would be a lot of torsional strain because there would be a lot of eclipsed groups coming off of the carbons. If you think back to what we meant by eclipsed groups when we drew Newman projections. So if cycloalkanes were flat or planar, and this is oftentimes how we draw them, right? Cyclobutane would look like this, right? And you can see what they mean about having the eclipsed groups, right? All of these groups would be eclipsed if it was flat, and we'd have a ton of angle strain. So it turns out that the cycloalkanes don't adopt these planar configurations, even though we kind of draw them this way in 2 dimensions. Almost all of them adopt some kind of puckered conformation, like we see here. And so it's not planar at all. And so that helps reduce the angle strain, and then it also helps reduce the torsional strain. Now, by far the most stable cycloalkane is cyclohexane, and we can see that based on these heats of combustion. So the lower the heat of combustion, the more stable that cycloalkane is. And so hexane comes in quite a bit lower than most of the others. Now, cyclohexane can adopt many different conformations, but the two most important are called the chair and the boat conformations. Both of these conformations actually have bond angles very close to 109.5, so neither one has significant angle strain. What makes the chair conformation so special is not only does it not have any angle strain, it also has very little torsional strain. If we look down these carbon-carbon single bonds and we look at the Newman projections, we can see, right, all of the groups coming off the carbons come out in these eclipsed conformations. And so this makes the chair conformation particularly stable. The boat conformation, if we look down the carbon-carbon single bonds, you can see that the groups coming off the carbons, the hydrogens in this case, are fairly eclipsed, and so that raises its energy. And then also we get what are sometimes called flagpole interactions between the hydrogens in these two positions, and so that makes the boat conformation particularly unstable. And so here are some of the different conformations. Uh, And it turns out that cyclohexane can actually interconvert between these two different chairs, going through a number of intermediates. But what we're going to focus on mostly in this course is looking at these two different chair conformations.